Hi, my name is Heather Elster. I'm a fifth-year PhD student and soon to be wrapping up with my dissertation defense in the next month or so. And my dissertation is looking at the development of cerebral oxygenation in premature infants. And how this came about was that many premature infants are at risk for what's called an intraventricular hemorrhage, or what's comparable to a head bleed or a stroke in adults. And not until these bleeds actually happen do we actually identify that it's happened. So up until that point, we don't know what children are at risk or not for these head bleeds to occur. And so the thought is that fluctuations in their blood within the head are what cause these head bleeds to occur. So the use of cerebral oxygenation, which is the amount of oxygen in the head, if we are able to monitor those or potentially pick up those fluctuations, then maybe we would be able to identify those infants who are at risk for IVH. So when I looked into the literature about cerebral blood flow, cerebral oxygenation, I realized that cerebral blood flow was very invasive to monitor continuously, and that cerebral oxygenation would be a great alternative. However, in the premature population, and really about 5 years ago, there were no normative values of cerebral oxygenation. So that's what I actually sought out to do, was to determine cerebral oxygenation values, normative values in the premature population. So for my chapter 3 in my dissertation, I actually establish normative values, which since the beginning of my PhD studies in the last year or so, one other group of researchers has published an article that confirms my findings, and my findings are for twice as many infants for almost twice the length of their hospitalization. So that's reassuring to me. And also within that data set, I'm looking at those infants who ended up with an IVH and those that did not. And so I compared those trajectories of cerebral oxygenation, trying to identify if those cerebral oxygenation patterns were different for those kids who ended up with a head bleed, and if so, if that happened within the first week of life, which is when these head bleeds occur, if that could be used as a predictive value in order to identify those kids in real time and figure out the next intervention in order to stop those head bleeds from occurring. Unfortunately, my research does not show that within the first week of life at this time with my data that we can identify those kids. However, over their whole entire hospitalization, I did find differences between those two groups of children. And so the thought is that if I had more severe IVH infants in my study, potentially there would be major differences enough to say that this is going to be helpful during the first week of life to identify those kids. So I think the next step with this research would be potentially looking at those children who end up with more severe grade 3 and 4 IVH, and seeing if those patterns of cerebral oxygenation differ from those who end up without an IVH diagnosis. And then with regards to the machine, the equipment, the cerebral oximeter, I think that also will have to take some more maturational steps as well. And that right now it provides us with the whole percentage, 78%, 80%. And I think we might eventually find that differences between infants who are at risk and not at risk might be very small, like 0.2 percentage points. And so I think as a clinician, that will be very hard to identify in order to intervene on those kids who might end up with an IVH. So I think the cerebral oximeter will also need to become more of a smart piece of equipment, to where we can program this equipment and to let it identify certain kids at risk and alarm us as a clinician that this kid is in trouble and that we need to intervene. So I think that there are different avenues where this research could definitely go, and hopefully I was able to contribute to the science.